The girl and the Swift test. Before we get stuck in, a little bit about me for all the new faces. I am Amy. Pronouns are she and her. Website cuteios.dev. Mastodon amy@iosdev.social. Work these days is Orderly Meds, which is a health tech wellness platform. And as well as that, I do my own project, which is a cycling-based journaling app called Ride Journal. Now, Swift testing. This is what we're going to have a bit of a look at tonight. Going to look at what is a test, the test macro, expect, require, suite, which is grouping, common test traits, tags, which need a bit of an extra explanation, async tests, test scope, and if anyone was on today's socials, they would probably have heard the Swift test evolution around attachments is now approved, so that's something coming soon. Okay, what is a test? Now, this particular talk is not a discussion on architecture or design patterns. Not going to say this is how you should structure your code or anything like that. There are no assumptions on IDE or CI environment. So a test is something that is repeatable. You can just keep running it and running it and running it, and it'll get the same result. Reproducible, same thing, get the same result. Idempotent, meaning that all of the setup, teardown is independent of any external factors, which, you know, it's just good testing practice. So let's get stuck in. Test. Test is pretty much the thing you'll be working with day to day. Documentation link from Apple. Apple's documentation is actually really, really good. Surprisingly, touch wood, because people know Apple's documentation historically has been a bit lacking, but this being a lot more modern and a lot more community driven is pretty up to date. So, a long time ago on the internet, this is how we wrote tests. Anyone remember this sort of days of iOS, macOS development? A few nods. Woo! Making Tim Oliver happy, even though he's over in Tokyo. Yep. I miss Tokyo. Tokyo's awesome. In joke. Okay. What was I going to say about this one? Here we've just got a lot of setup, teardown. We're using a mocking framework because Objective-C allowed us to do some really, really funky stuff with messaging and objects that allowed for pretty much swapping things in and out as you go, which you don't get as much in Swift. Translating this to say something from a year and a half ago, you would be writing tests like this. This is all in Swift, but you're still using XCTest in there. So you've got your asserts, your expectations, all of that stuff in order to see what the actual test and the behaviour is. Again, this is a bit more convoluted. You're having to remember what these particular Objective-C bridge to Swift things are. And now we get to test as the macro itself. So, trying to remember when macros were introduced. It was it 2021? Around that era. We've had them for a while, which is actually quite remarkable. Part of Swift 5, I'm pretty sure. I'm probably going to get corrected on this one, but let's just go with that sort of time. What we have here is we're defining a function as a test using the test macro. Then within it, we've got these expectations. So using the expect macro to go, we want this thing to be true, which is what we have. So I've got a couple of expressions there which produce a Boolean result. And that is, at its most basic level, what a test is. Now you can just throw this function into a file as part of your test target or your test package and it will work. As long as you're importing testing, away you go and you've got yourself a test. But if that's all it was, we'll be a bit lacking on what we can do. So let's look at an example of one with all the trimmings. So here we've got this test which runs through some code, providing a few different inputs and some expected outputs. Those inputs and outputs are there as part of the arguments, which is taking two arrays, zipping it together. So you've got first 0th element in the first array, 0 in the second array, so on and so forth as your arguments to this function. Oh, bugger off, Siri. Okay, so that's what you've got, which you're defining in the test macro and also in the function you're declaring. And then you get to use them in your test body itself. So you can go, cool, let's need to actually see what's there. Pretty much it's doing a setup and going, okay, once I've run all of this condition, is my expected output going to match what's there? And yay, it is. Here we've got something that's repeatable, it is reproducible, it is idempotent, all the good things that a test needs to be. As well as that, if you're familiar with Xcode, and I'm going to break my rule about mentioning specific IDEs, but typically the name of the test that you take from gets taken from the actual function. Back in XCTest days, it was test something, something, something. Here it is just something, but you can modify that in the macro. So you've got here show next walkthrough step, which is pretty cool because that's a much more descriptive title to our test than what we're naming the function. We can also provide some traits there, which are tags. In this case, we are saying this particular test is tagged as a walkthrough test, and you can do some nice things with tags as well. So we've got our test, which is just our sort of vanilla test, and then we've got one which is all the trimmings. Pretty cool. Next thing to cover is expect. So again, Apple's documentation, I'll leave it up for a little bit if you want to take a picture of it or just rely on the stream. It's all pretty cool. But there are two real flavors of expect, being you expect a condition to be true, which is the top example. We've just sort of going, we want this stuff to produce a Boolean true result, but you can also expect a particular closure to throw. So in this case, we are wanting the function. I'm omitting all of the setup around it, so we not worrying about the inputs there, but we're expecting the output of calling that function to throw an error. Now, this is pretty good, and yeah, it works. I like it. So we can test a true condition, and we can also test that an exception gets thrown, which is fairly common in Swift-based apps. Next one is require. If you look at the documentation link here, it's actually the one for expectations, so you expect macro. Require is just very similar, so they've put it in the same documentation. What required does is it'll actually stop execution if the particular condition has not been met. With expect, your flow of execution continues. It just shows an error. With require, it will go, I do not want to do anything more if this condition is not met. So here, what we're doing is we're using it like we would XCTest unwrap to unwrap an optional value and make use of the result. So in this case, if that's nil, it will result in a thrown error and your execution will stop. Next one is suite, which is another macro. Here, Apple's documentation is called organizing tests. Makes a bit of sense because you can have standalone tests in a function in a file. That's all well and good, but sometimes you want to group them together, form a bit of a hierarchy. That's what suite is for. So here you apply the suite macro to a structure which is a value type, and then within that you define all of your tests. The beauty of suite is that you can actually nest all of these. So within a suite you can have a suite, you can have a suite, and it's turtles all the way down, which is pretty cool. Messy, but pretty cool. The other benefit here is quite often you would have the tradition, whether it's good or bad, I'm not going to say, tradition of naming your test type, the type you're wanting to test, and then appending tests. By applying a name to the suite macro, by applying a name to the suite macro, you can then name it whatever you want. So in that way, if you wanted, you can actually remove your grouping of tests from the actual test type itself. I'm still a bit more stuck in my ways because I'm old. Don't ask how old, I just am. In that I will always use, say, test subject and group based on the type. You don't have to, you can group based on whatever you want, which is pretty cool. All of these things allow you to be very expressive in how you write your tests. Next one we're going to look at is test traits. So, what is a trait? Trait can be something like a tag. It can be whether a test is enabled or disabled based on a particular Boolean condition. You can also set a time limit on the tests, but let's be honest, if your test's taking longer than about 2 or 3 seconds, you're probably doing something wrong. Yep. Yes, let's not talk about measurement tests. They're allowed to take as long as you want, but for a basic testing of a unit, if it's taking longer than a few seconds, there's something else going on. You can use time limit here to pretty much cancel a test if it goes over a period of time. If you're paying by the minute for a CI service, such as Xcode Cloud, this might be useful if you've got tests that are not nice. We'll leave it at that. You can also have a bug tag. Calling it a tag's a bit of a misnomer. It is a trait where you just say, this particular test belongs to a bug. Here is your identifier for the bug in whatever bug tracking system you want. Again, all of these allow for you to be super expressive in how you write your tests, how you determine meaning and stuff like that, which is pretty cool. Next one, tags. So I mentioned it just before. Showing it again because documentation is its own little thing with its own caveats. In order to define a tag, you do an extension on the tag type. It does need to be an extension when you define it. Just using the macro doesn't work. Apple's documentation is very explicit about this. So you define the extension, then you define a static variable, type self, and you use the tag macro. Then when you get to using it, when you define your test, you say tags, here are my list of tags such as journaling and system, and away you go. And it works really, really well. Advantage of doing this is it provides another form of grouping and identification on your on what you run. If you're using something like Xcode and Xcode Cloud, you can set up a test plan. Those test plans allow you to specify and filter tests based on different tags, and those tags then, you can go, here's my test plan for running everything that's system related or journaling related, and only run a subset of those tags. Async tests. Now, this quite often is where a lot of people run into issues because Combine is its own world of pain to test. Not going to talk about it. But so is Swift concurrency in that quite often you want to have your execution or your tests handled in a particular way. So let's look at an example. Here what we've got is we're expecting that once the onAppear of this particular view model has been called, we want a values count to be 1. Pretty straightforward. What's slightly different here is that the loading of those pictures happens asynchronously. So we've mocked out the repository, in this case is our data access to Swift data or whatever else you have, and it's using that by providing a completion handler. This is all getting into the way I structure this particular app, but as part of that it's going, we'll wait for this confirmation before doing any continuation of flow within the function. And that particular confirmation happens within something else that is called asynchronously. So it won't actually get down to the expect macro until that confirmation is called. This is pretty cool to make sure that all of the conditions for your test are set up by the point you get to that expect, which is what you're actually wanting to test. Apple's documentation here is pretty good, covers a few different conditions around what the actual confirmation function expects. So you can go, I want it to be called once, many times, up to a number of times, whatever condition you want. Test scoping. So Swift 6.1, which was released a couple of weeks ago, introduced what's called test scoping. Test scoping is itself a test trait. I haven't gotten to play around with this too much. So the example here is from Apple's documentation. So here, got the test being set up. Then we've got the type, which is conforming to test traits and test scoping. As part of that protocol definition, you need to do, what is it called? The provide scope function, which takes in your test line, test file, and also the body of the test. And within that provide scope, a way to conceptualize it is like your setup and your teardown methods back in XCTest, where you're needing to do a whole heap of construction around your test in order to make it idempotent, and then tear it down at the end. This is what you're doing here. The example makes use of a singleton, which we all know, well, I assume we all know the bad ideas around global state and its mutability, but what we have here is current is a task local variable. So we can set it with a value, execute a particular task, in which case we have here our test, and then it all gets torn down at the end, which is pretty cool. This is a nice way to isolate your tests and make sure any setup and teardown are reusable. And it's also going to be reusable across particular test suites or tests themselves, because it's not bound to the init of a value type, which is previously the preferred way of doing setup for a test. Attachments is today's very fun announcement. Now, in XCTest, there's XCT attachment, I think. If anyone's done XCUI tests and captured screenshots via it, I believe, don't hold me to it, that this is an example of XCT attachment. Attachments is the new Swift test way of achieving that. So its purpose is for, say, a CI environment. When the environment fails or where a test fails, you often want a little bit more than just a log message going, this did it not equal that. Sometimes you want to get what was the setup conditions and other things around it. Attachments will allow you to do that, which is pretty cool. I like it. I'll probably play around with it. May or may not have a good use for it, but I expect, I'm going to assume and guess that something like attachments will have a dub video. Hopefully. It's kind of that timing. Did I mention it was 61 days until dub.dc? Okay, that's it for the talk.
Thanks, Amy. That was really great. Learned a lot from that. What would you say are some of the benefits of Swift testing against kind of XCTest, and what are some of the hindrances of problems you've run into with Swift testing?
Oh, Swift testing and its differences to XCTest. If I can, I will always default to Swift testing, mainly because as a paradigm, it suits my style and the way I write apps and write code. XCTest is a lot more procedural in that it's sort of like, do this, expect that, do that, expect that. Whereas Swift test is a lot more expressive, and even though it's describing a unit that you're typically testing, it feels a lot more behavioural in how you actually write the tests. That's my experience with it. As always, pick whichever solution is going to suit the app you're writing and the team you're a part of, but I err towards Swift testing for those reasons.
Would you migrate old tests, or would you just leave them and just start write new tests in Swift testing?
Again, this is what is the capacity of your team question. I, in my own personal projects, just go, nope, rewriting, and away I go. I'll spend a day, whatever it takes, to migrate across. If you're in a larger organisation, app that's been there for a couple of years, many developers, doing a clean cut from XCTest to Swift test may not work. The advantage of something like Xcode is they can live together. Even within, say, a Swift test or suite, you can still use XCTest expectations and all that. So you don't need to go all the way to Swift testing at once. You can do it gradually.
Thanks. Yeah, it's been maybe a few years since I've done some serious Swift testing, and so a lot of that's like I don't know what they call it, selectors in Swift, like the hashtag expectation is new, and it looks really like powerful and awesome. So back when I used XCTest case, I would use Nimble a lot for matches, just because the built-in ones weren't really powerful. So can you do like similar kinds of things, like this match this array in any order and that kind of stuff? Can you do that with
Oh, okay. A brief history of testing and Swift in about 30 seconds. So back in 2014 when Swift was first announced, during that dub is when the Quick and Nimble project started. Back at that point in time, behaviour-driven testing and BDD, behaviour-driven development, was all the rage. So people wanted to go, yay, we have now this expressive language. If people remember pre 1.0 Swift, it's, yep, okay, sidetracked. That's where it came from. Now, along with that, all of these matches sprung up because that was the style of coding at the time. And those matches match a bit more closely to the, I'm going to call it funkiness of Objective-C, which is you're able to do things like mocking and do assertions based on the amount of times a particular message is sent or method is called quite well in Objective-C. So they were trying to emulate that and that behavioural style a lot. Can you then reproduce that in Swift testing? Sorry, not as much, because how you write those tests is going to be slightly different, in that you're not going to go, this dot matches that. You're going to go, here's a Boolean expression. Am I expecting it to be true? Or am I expecting this closure to throw an exception? So slightly different. I think SwiftTest is a little bit more expressive than the BDD style of Quick and Nimble. Having said that, I believe Quick and Nimble are still maintained. They're just not as common in practice.
Thanks. Yeah, I guess it's always better to use the kind of first-party stuff built into Swift or Xcode. Just because I remember using Quick and found that it didn't integrate perfectly with Xcode's test runner and things like that. So
oh yeah,
if there's a way to, it looks like it's quite expressive now, and
yep.
Yeah, definitely
Like,
want to check it out.
I remember one of the big pain points around Quick and Nimble in the early days was when you ran the tests, you could not run an individual test. You had to run everything within the test target, just because of the way it did all of its new stuff. To do a complete and utter tangent, you mentioned @selector, which is an Objective-C macro, which is very different from a Swift macro in its style, kind of, but Swift macro is a lot more powerful than the old @selector, the shorthand syntax for dictionary and array, which were at curly bracket, at square bracket, and all of that. So even though they're both macros of a variation, it's probably not quite as good to do a one-to-one with them. They're different approaches, same terminology.
Any more questions? Awesome. Thank you, Amy.